Okay, so in 1-6, we're going to talk about polygons. What are polygons, how you classify them as convex or concave, and then some information about the side lengths. So what is a polygon? Poly actually means many. So polygon means many angles. It's defined as a closed plane figure formed by coplanar segments, and we refer to these segments as sides, such that all three of these things happen. One, each side must intersect exactly two sides, one at each endpoint. No two sides with a common endpoint are collinear. And each endpoint of a side is a vertex of the polygon. So I'll give you a little bit of visual on this in just a second. The second thing says no two sides with a common endpoint are collinear. So the first question is, by looking at something, could you tell what if it was a polygon? So remember that each side has to intersect exactly two sides at its endpoint. So if I were to look at this drawing here, right, this is a side. It intersects two other sides at its endpoints, okay, and that would happen all the way around that diagram. The second thing, so what this means is basically I can't have a side that looks like this and then another side that looks like this. This would not be, those wouldn't count as sides of a polygon, okay? Those would be two, that would be collinear. The last thing is you can't have any holes because it would basically mean that it doesn't intersect another side at two endpoints. So if I look at A, would you say that A is a polygon? Yes, okay. This is yes. How about B? Good. This segment is not touching two other segments at its endpoint. So B is not. Okay, and when it says explain, I could say something like sides not intersecting two other sides. How about C? Is C a polygon? No, this time it would be intersecting too many sides, right? If I were to look at this side here, this could either be this side where it would be intersecting too many sides, or there's two segments whose points would be collinear, right? Okay, so I could say either one. The sides are intersecting more than two other sides, or two segments are collinear. Either way, it wouldn't work. How about D?
Yes.
Yes, D is a polygon. How about E? No. So if I look at each segment, they are intersecting two other segments. But what's wrong with where they're intersecting? Good. It's not closed, it's not at the endpoints, okay? So this is a no. You can say not closed. You can say sides not intersecting. At both endpoints. Okay, so your reasoning should be in your own words, but it could be something along those lines. Questions on just identifying whether or not they're polygons. Anybody still copying that down? Okay. All right, convex polygons. So a convex polygon would be one in which no line that contains a side of the polygon contains a point in the interior of the polygon. So if I were to extend each side, would any part of that line that is extended go into the interior of a polygon, okay? If it does, then it's not convex. They actually call it concave, okay? If it doesn't, then it's convex. So if I look at this little example here, if I extend all these sides in either direction, none of those lines cross into the interior of a polygon. Same thing here, 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 or all these sides, God bless you. If I were to extend them all, none of that crosses into it. If I had something like this, if I extend this side, it crosses into the interior. So this is not convex. So if it was like, looks like a chunk of it was taken out of it, it's still a polygon. It's just not convex. So that non-convex is called concave, okay? Concave has a line that contains a side of the polygon that contains a point in the interior of the polygon. So if I were to extend the sides, and it doesn't have to be all of them, like this one would not go into the interior, this one would not, this one would not, but this one does. So if it would cross into the interior, then it's called concave. If you think about it, it looks like a little piece of it has caved in, right? Like if that was a little house, it looks like the little roof is caved in, something like that, okay? Okay, this is classifying polygons. So these are all the names of the polygons based on how many sides they have. Hopefully most of these you know. There might be a couple on that list you don't know or needed a refresher, but 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 a decagon, and 12 dodecagon. There's no special name for 11. I don't know why 11 got left out, but it did, okay? Anything that there's no special name for, that n-gon, you would put the number of sides. So a polygon with 11 sides would be called an 11-gon, okay? If it was 121 sides, it would be 121-gon, G-O-N, okay? I would say that the two people tend to switch up is 6 and 7, hexagon, heptagon. Look at the word hexagon, it has an X in it, just like the word 6, okay? 7 is heptagon.
Is there, like, for N, is there a dash?
Yeah.
Maybe if I write it off.
Yeah, technically it's n-gon, so it would be like 11-gon, okay? And you'll see n-gon a lot. It means it's a polygon, and you have to determine how many sides it is. So you'll actually see n-gon in some sort of direction sometimes. And it just means it's a polygon it's not giving you how many sides it is. Okay, equilateral, equiangular, and regular. So some vocab terminology here. Equilateral is a polygon in which all the sides are equal in length or are congruent. God bless you. Equiangular, and it has the little word almost angle in there, so hopefully that's how you can tell the difference. Equiangular is all the angles are congruent. And if it is both equiangular and equilateral, then it's regular. So all the sides are congruent to each other and all the angles are congruent to each other. Okay, so example 1 says, tell whether the figure is a polygon and whether it is convex or concave. All right, so is A a polygon? No. Is B a polygon? Yes. Convex or concave? Convex, good. Is C a polygon? No. That side is an arc, right? Is that a segment? No. Okay. So it's got to be a segment, which means it's got to be a straight line. Can't have any curves to it. How about D? Yes, and concave, good. So a circle obviously can't be a polygon, right? That's a curved edge. Think about it when I gave you that list. What's the first thing that started with? The list of polygons, the names. A triangle, right? There was no circle on that list. Okay? There's no two-sided figure. There's no circle. All right, now it says classify the polygon by the number of sides and then tell whether the polygon is equilateral, equiangular, or regular, or none, and explain your reasoning. So what does equilateral, equiangular, regular mean, basically? All right, so A is what? How many sides? 6 sides, which makes it a hexagon. Is it equilateral, equiangular, or regular? Regular. Okay, why? What does regular mean? Good. All sides congruent. All angles congruent. How about B? Quadrilateral. And equilateral, equiangular, or regular? None. Okay. So the sides, there's 2 with 2 tick marks and 2 with 1 tick mark. And then the angles, there's 2 with 1 and 2 with 2. So there is congruency going on, but not all the way around. Okay, how about C? Dodecagon. Okay, and equilateral, regular. Okay, look at all the angles on the inside. Are all the interior angles the same? Yep. Are all the little sides the same? So this is regular. And the same reasoning. All the sides are congruent and all the angles are congruent. Questions? Here's a little bit of overlap with algebra. So there's always going to be a constant bring in of the algebra, right? Yay, just so you don't miss it. Okay, this says a table is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal table. Find the length of the side. God bless you. So what one word in that whole little paragraph is probably the most important thing? Regular. What's it telling you? All the sides are equal. So all I have to do is take this side and set it equal to this side. Subtract the 3x.